let's talk about your home network. It's probably just one big flat network, right? Your laptop, your phone, your smart TV, maybe your friend's tablet when they come over, everything is just all together. And that, my friend, is a huge security problem we're going to fix today. I'm going to say that one more time because it's really the most important thing you'll hear. You just can't keep all your different devices on the same network. It is probably the biggest security blind spot for most people, and we are absolutely going to tackle it. Just think about it for a second. You know that cheap smart light you bought online? Well, if that thing gets compromised, the attacker now has a direct path to everything else. We're talking your personal computer with all your private files. When it's all one big network, a single weak link can basically bring down the entire house of cards. So consider this a security mission. Our objective? To take that one giant, risky network and slice it up into smaller, safer, totally isolated zones. And the tool we're going to use to do this is one of the most fundamental concepts in all of networking, subnetting. So here's the game plan. We're starting with our single, flat network. From there, we're going to use the power of subnetting to strategically break it apart. By the end, we're going to have 4 separate, secure networks. You know, one for your personal stuff, another for those kind of sketchy IoT gadgets, a third for guests, and maybe even a fourth for a home server. All right, so how do we actually do this? Well, the secret is hiding in plain sight. It's in something you've probably seen a million times but maybe just ignored, this subnet mask. We're going to learn how to manipulate it. In fact, you could even say we're going to hack it to make it do what we want. To really get this, you need to know that every IP address is made of 2 parts. You've got the network bits. Think of that as the street name. It tells everyone which network or street you're on. Then you have the host bits. Those are like the house numbers on that street, identifying each individual device. And this right here is the absolute key to our entire mission. When you realize you need more networks, more streets, you have to get that address space from somewhere. And the only place you can get it from is by stealing it from the part of the address that's meant for the devices. So here's the deal. We decided we want 4 networks. To get 4 networks, we have to borrow bits from that host part of the address. And the math is actually pretty simple. 2 to the power of whatever number of bits you borrow, that's how many new networks you get. So 2 to the power of 2 is 4. That means we need to hack exactly 2 of those host bits. And boom, this is the result of our little hack. By flipping those first 2 host bits and saying, hey, you're network bits now, we've literally changed the boundary line. Our old subnet mask of 255, 255, 255, 0 is gone. Our new one is 255, 255, 255, 192. We have just fundamentally redefined our network space. Okay, so we've officially changed the rules of the game with our new subnet mask. Now let's figure out what this new playing field actually looks like. It is time to calculate our 4 brand new networks. Right, so we know we have 4 networks, in theory. But what are their actual addresses? You know, where does one network stop and the next one start? How do we map out these new boundaries we just created? The answer to that question comes down to finding something called the increment. You can just think of it as the magic number. It tells us the exact size of each of our new subnets. And once we know this one number, everything else just clicks into place. And for our mission, that magic number is 64. Why 64? Well, it's the value of the last host bit we flipped over to the network side. This number, 64, is literally the key that's going to let us draw our new network map. And here they are. Just look at that. Mission accomplished. Using our magic number, our increment of 64, we can just lay out our 4 new networks perfectly. The first one starts at dot 0 and goes up to 63. The next one picks up right where that left off, at dot 64 and goes to 127, and so on. 4 perfectly divided, totally separate networks. Awesome! Now we can actually put this to use. That first network, that's for your trusted personal gear. The second one, starting at 64, that's the penalty box for all your insecure smart home gadgets. The third network is a safe little sandbox for your guests. And that last one, we can use it as a special zone, a DMZ, for something like a home server. The important thing is, each one of these is now isolated. So let's just zoom out for a moment and really appreciate what we've accomplished here. This isn't just some clever little networking trick. This is a fundamental shift in how you control and secure your own digital world. Now, of course, there's always a trade-off, right? We stole those bits from the hosts, which means each new network has fewer addresses for devices. We went from about 254 devices on one giant network to just 62 on each of our 4 new, smaller ones. But honestly, For the massive security boost we get, that is a fantastic trade to make. And I gotta tell you, what you've just learned isn't just for your home. Subnetting is a core foundational skill used in pretty much every single area of IT, from cloud computing to huge enterprise networks to cybersecurity. You've seriously just taken a massive step in understanding how the internet is actually put together. So we did it. We successfully built the walls between our networks, creating these secure little fortresses. But this immediately brings up the next big question, doesn't it? How do we let some traffic through when we actually need it to? After all, you've built the walls. Now you have to decide who gets to open the gates.